Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 18.3, which is going to deal with the volume of cones. Now, for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to find the volume of a cone. So we're moving from prisms, cylinders, and pyramids to today, where we are going to be talking about a cone. So a cone is the following 3D shape. A cone has a single circular base. It has one rounded edge that all meets together at one point called the vertex. So this is a cone. A cone is kind of a combination of a cylinder and a pyramid. It's like a cylinder because it has a circular base and because it has a rounded edge. Now, it's like a pyramid because it has one base and all the sides meet together at one point. So it's a combination of both a cylinder and a pyramid, which gives us our cone for today. Now, we're going to go through and find the volume of cones throughout our notes, and that's what we want to talk about next. So how do you find the volume of a cone? To find the volume of a cone, we want to use this V equals 1/3 times pi times r squared times h. So that is going to be our lifeline for today. Volume equals 1/3 times pi times the radius squared times the height of the cone. So you need to know two things about every cone to go through and find the volume of it. You need to know the radius, which the radius, if you recall, is going from the center to the edge of the circle, that distance. And then the height of the cone is going to be the straight up and down height of that cone. Now, height for cone is not the height that goes along the side. Okay, so if it goes along the side and it's not straight up and down, this is referred to as the slant height. Okay, the height should be straight up and down, and that's going to tell you the height overall of the cone. So if you're told the side of the cone, that's referred to as the slant height, whereas we want the height. And I'll indicate what problems are using the slant height and how you can figure out the height if they do not tell you. So, two things you need to know, the radius and the height. So, let's go ahead and get into example 1 for today, where we go through and find the volume of cones. Alright, so example 1 is going to ask us to find the volume of the following cones and round to the nearest hundredth if necessary. So example 1 is different sorts of cones, parts A through F. And all we need to do is just go through and find the volume of them. So if we take a look at example 1, part A, so we are given our cone right here, and they tell us two different dimensions, 11 yards and 4 yards. Now, based off this picture, we know that the 4 yards refers to the radius of this cone. So we know our radius to be 4. And this 11 right here, because it's going straight down the middle of the cone, that is our height of the cone. So 11 is the height of this cone. So we know our radius, we know our height. That is the two things we need to know about our cone to go through and find the volume of it. So, using the volume formula, this V equals 1/3 pi r squared h. We're going to go through and plug in the value of 4 for r and 11 for h to help us go through and calculate the volume of this cone. So we're going to go through and plug everything in. So it's 1/3 pi times 4 squared times 11. We knew our radius to be 4, we knew our height to be 11, so we plug those in for r and h. Now we have 1/3 pi 4 squared times 11. So from here, all we need to do is just go through and calculate this in our calculator. Now, I find it's helpful to kind of simplify some parts down before we type it all into our calculator. What I like to do is go through and simplify this. So we're going to do 4 to the power of 2 and then times 11 to hopefully simplify some multiplying later on. Alright, so if we do 4 to the power of 2, we get 16. And if we do 16 times 11, we end up with 176. So we now have 1/3 pi times 176. That should help us eliminate some operations we need to type in later and just have us multiply 3 different parts. So with that said, let's go ahead and finish calculating our volume. So we're going to do 1/3 times pi times 176, and we get 184.306. And because we went around to the nearest hundredth, that's 2 decimal places. So instead of 0.30, we're going to do 0.31. So we get 184.31 yards cubed. And that is the volume of our cone. And that is how you go through and find the volume of any cone. You just need to know your radius, you need to know your height, then just plug everything in to your equation, and that will tell you the volume of your cone. Alright, so with that said, that's really how you go through and find volume. Now, the following problems and examples that I want to run through have a slight little different twist. Either with B, they don't tell us our radius, or with C or D, they don't tell us the height, but they tell us the slant height. So we're going to talk about how you can go through and find the volume in both of those situations. So for part B, let's go ahead and move this up. For part B, they give us our following cone. They tell us 16 miles and 16 miles for both parts here. Now, this 16 miles right here does refer to the height of the cone. This 16 miles refers to the diameter of the cone. So, whenever we know the diameter, to figure out the radius, we just had to take the diameter and divide it by 2. So if we did 16 divided by 2, we get 8. So whenever you're given the diameter, all you have to do is just take that number, divide by 2. That tells us our radius, in this case, is 8. Because the height does go straight down through the middle, we know that that is our height for 16. So now that you know your radius and you know your height, all you have to do is just plug everything into the volume formula and calculate from there. So volume of a cone is 1/3 pi r squared h. So we know r to be 8 and we know our h to be 16. So let's go through and plug all of that in. So it's 1/3 pi 8 squared times 16. What I'm going to do is evaluate this 8 squared times 16. So 8 to the power of 2 gives us 64 times 16 is going to give us 1024. So I now have 1/3 pi times 1024. So from here, I can more easily enter this into my calculator. So we're going to do 1/3 times pi times 1024. And when we do that, we get 1072.33. And that is the volume of our cone for part B. So 1072.33 miles cubed. So that is how you go through and find the volume of a cone when they tell you the diameter and you need to figure out the radius. Okay, so we've run through two examples on how to find the volume of a cone. One, strictly where they told us the radius and the height. One where they told us the diameter and the height. Now let's talk about some examples where they don't tell us the height. And that is what we're going to see in parts C and D. So if we look at C, they tell us two different numbers. They tell us 2.2 and 1.8. Now the 2.2 is going to refer to the diameter of this cone. So we don't want the diameter, but we want the radius. So let's go through and figure out the radius real quick. So if the diameter is 2.2, we're going to divide that by 2 to tell us our radius is 1.1. All right, so we now know our radius. Our height, though, is not told to us from this diagram. Okay, the height would be this length right here, but they do not tell us what that length is. Instead, they tell us the slant height, the length down the side of the cone. So whenever they tell you the slant height going down the side of the cone, and they don't tell you the height, you need to do the following steps. Okay, they tell us the slant height. We figured out our radius from the diameter. So we now know what this purple part is, which is 1.1. We know the green part is 1.8, so we need to figure out the red part for our overall height. Now, if you notice, they have indicated with a little right angle box here that this is a right triangle. Whenever we have a right triangle and we need to know an unknown side length, we are going to use the Pythagorean Theorem. So, you have to use the Pythagorean Theorem that a squared plus b squared equals c squared to figure out the height of your cone. Now, when you are going through and doing this, know that your slant height is always your hypotenuse, that c squared. This height overall is going to be either your a or your b, and the same thing for the radius. But know that this 1.8 needs to be that c squared. So if we go through and set this up to figure out our height, it is going to be 1.1 squared plus h squared for the height equals 1.8 squared. So 1.1 comes from the radius, h is going to come from what we want to figure out the height to be, and then 1.8 is from the slant height. So all we have to do is go through and figure out what h equals. We're going to go through and evaluate the squares. So 1 squared gives us 1.21. Plus h squared equals, and then we get 1.8 squared, and we get 3.24. All right, so now that I've evaluated the squares, we want to get h alone. So we want to subtract the 1.21 over to the right. So we're going to do 3.24 minus 1.21, and we end up with 2.03. So h squared equals 2.03. Now from here, because we have an h squared and we want to solve for h, to get rid of that squared, we're going to take the square root of both sides. So when we take the square root of both sides, that's just going to leave us with an h, and then our answer for the height. All right, so the square root of 2.03 is going to give us 1.4278, and so on. So we're going to just round this to 1.42 because the number behind 2 is 4. So that means we're just going to leave it as 2. So our height is 1.42. And that tells us the other part that we need to know to go through and find the volume of this cone. So we figured out the radius because we took the diameter 2.2, divided it by 2, gave us 1.1. We now know the height to be 1.42 because we used the radius and the slant height in the Pythagorean Theorem to tell us that it's 1.42. So now that you have your radius and you have your height, we can go through and plug everything in to the volume formula. So it's V equals 1/3 pi r squared, and our r is 1.1, times the height, which is 1.42. So we're just going to go through and calculate this to figure out the volume for C. So 1.1 squared times 1.42 is going to give us 1.7182. No, it should be 1.7182. All right, so from here, we just need to go through and multiply it with everything else. So 1/3 times pi times 1.7182, and we get 1.7992. Now, it wants us to round to the nearest hundredth, so that's 2 decimal places. So because this is a 9 behind the 9, that means we got to round 9 up to 10. So this is actually going to become 1.80. Inches cubed. And that is the volume of our cone for part C. So now you have seen an example where they tell us our diameter and they tell us the slant height. So we need to go through and figure out the height before we can figure out the volume. All right, now from there, the rest of example 1 is just kind of more variations of them not necessarily telling us either the height or the radius, and you have to go through and use the Pythagorean Theorem to do that. So, for example, for part D, they tell us that the diameter is 2.4. So if we know the diameter to be 2.4, that means that our radius is half of that, which is going to be 1.2. So we now know our radius. Then they tell us the slant height is 3.9. So that's not the height of the cone, yet it's the slant height. And what we need to know is what is the height of this cone. So you have to figure out what the height of the cone is by using the Pythagorean theorem like we did in C. So we would do 1.2 squared plus h squared equals 3.9 squared to figure out the height. So to set it up, just that way you have an example, it would be h squared plus 1.2 squared equals 3.9 squared. Remember, your slant height is always going to be the hypotenuse, the number on the other side. So we have h squared plus 1.2 squared equals 3.9 squared. Now that you have that set up, you would go through and solve. So evaluate the squareds, subtract this number over, and then take the square root, which tells us that the height is 3.71. So from there, we know the radius to be 1.2, we know the height to be 3.71. All we need to do is just plug those values into our formula and figure out our volume. So if you're plugging everything into the volume formula, the 1/3 pi times r squared, which is 1.2, times by the height, which is 3.71, you would just go through and calculate it there, and you would be told the volume to be 5.59 inches cubed. So D is very similar to C in the fact that they tell us our diameter and they tell us the slant height. You have to go through, take your diameter, divide it by 2 to figure out your radius to be 1.2. Once you have your radius, you're going to use the radius and the slant height to figure out your height by using the Pythagorean theorem. Then once you know your height and you know your radius, then you can plug everything into the volume formula and figure out what your volume is. So if you are not given your radius, yet you're given the diameter, just divide it by 2, that tells you the radius. If you do not know the height, you need to go through and use the Pythagorean theorem like we did in parts C and D. Okay, that might very well pop up, so please be aware that if they don't tell you straight up and down what the height is, but they tell you along the side, you have to use the Pythagorean theorem. Alright, so that is example 1, parts A through D. On the back side, before we get to example 2, we have a few more where they would ask us to go through and find the volume of these cones. If we look at E, it's very similar to parts C and D. They tell you the slant height and they tell you the diameter. So you would have to divide this by 2 to figure out your radius. And then you would have to use the radius and the slant height to figure out your height by using the Pythagorean theorem. So I'm going to leave E for you. You can reference it in my completed notes if you'd like. If you want to go through and see if you can figure it out, know that the volume for E, you should get 50.76 feet cubed after you do all the work. Okay, and to give you another bit of a hint, the radius, because the diameter is 5.9, the radius is 2.95, and the height, using the radius, using the slant height, and the Pythagorean theorem, you figure out the height to be 5.59 0.57. Okay, so figuring out the radius from the diameter, you just divide by 2. Figuring out the height using the slant height and the radius and the Pythagorean Theorem, you figure it out to be 5.57, and then you can just plug everything into the volume formula. Alright, now, the last one I want to talk about is F, and the reason I want to talk about F is because they tell us our slant height is 22 centimeters and our height is 20 centimeters. So, joyously, we know the height, so we don't have to use Pythagorean Theorem to figure out the height, but they do not tell us our radius or diameter. So, F is going to be a situation where they tell you the height and they tell you the slant height, but they do not tell you the radius or the diameter. If we knew the diameter, we could just divide it by 2. But we don't know that, and we don't know anything else about the radius. So, unfortunately, the Pythagorean Theorem doesn't go away, yet we are going to use it to figure out our radius for this cone. Now, if you have to figure out the radius when you are told the height of the cone and the slant height of the cone, you need to use Pythagorean Theorem like I said. So we're going to use 22 and 20 and then this r. So it's going to be r squared plus 20 squared equals 22 squared. Again, the slant height, the height or the length of the side of the cone is always your hypotenuse, the one that needs to be on the end. Your radius and your height are going to be the first parts, the A and the B, of the Pythagorean Theorem. Alright, from there, you just go through and evaluate the Pythagorean Theorem, and we figure out R to be 9.17. Okay, to run through it on the calculator just to show you. Okay, what you'd have to do is evaluate the square of both of these. So if we did 20 squared, you get 400. If we do 22 squared, you get 484. So you're going to take the 484 and subtract it by 400 to get R alone. So that leaves us with 84. And then because we need to figure out what R is, not R squared, you take the square root of 84. And that tells us our 9.17. So now that I know our radius, we know the height is 20 because they told us that this time. So now that I know both of those measurements, we can go through and plug everything into the volume formula. So it's V equals 1/3 pi r squared h. We know our radius to be 9.17 and our height to be 20. So we're going to plug those in for r and h. So we now have 1/3 pi times 9.17 squared times by 20. So from here, all you have to do is just evaluate your equation. So if we do 9.17 squared times by 20, and then we multiply it by 1/3, and then multiply it by pi, we get 1,761.15 centimeters cubed for our volume. So that is how you go through and find the volume of a cone, and that's going to be a majority of what you have to do for section 18.3 on volume of cones. Okay, we've talked about when you're told the radius and the height, how to find the volume. We've talked about when you're told the diameter, how you figure out the radius, and then when you're told the height. And then we've talked about when you are not told the height, how you use the Pythagorean Theorem to figure out the height. And then we've also talked about when you're told the slant height and the height, how you figure out the radius. So you have a slew of examples that you can reference on the completed notes or in the videos as you work through the homework. So you should know how to find the volume when you're strictly told radius and height, when you're told the diameter and the height, when you're told the diameter and the slant height, and when you're told the slant height and the height. So, with that said, that's really kind of most of it. Example 4, it says here, I don't know why I didn't put 2, but example 4, we'll just go with it. Wants you to find the volume of the composite figures. So you would have to go through, figure out the volume of the cone and the cylinder for part A, and then add them together. For part B, you would have to figure out the volume of the cylinder and of the cone, and then subtract them. Now, a way that's to help us with this, okay, a cylinder, its volume formula is pi r squared h, and the cone is 1/3 pi r squared h. So for A, you go through and figure out the volume of both. You add them together because it's adding it on top. For B, you're removing it, so you have to subtract. Now, let's go ahead and take a look at A. So for part A, we need to go through and figure out the volume of the cylinder first. So for the cylinder, we need to know the radius and the height. They tell us the diameter is 16, so that means the radius is 8. And then they tell us the height of the cylinder is 19. So it's going to be pi r squared, which is 8, times by the height, which is 19. We go through and calculate that all in our calculator. We get a volume of 3,820.18. Once you have the volume of the cylinder, okay, we have to figure out the volume of the cone. So for the cone, it's going to be 1/3 pi r squared h. The radius of the cone is the same as the radius as the cylinder, so that's 8. Now the height of the cone, they tell us the overall height of this shape is 32. So how does that help us know the height of the cone? Well, if we know the overall height is 32, they tell us the height of the cylinder is 19. We just have to do 32 minus 19 to tell us the height of the cone. So we're going to do 32 minus 19, and that tells us the height of the cone is 13. So then we just take 1/3 pi 8 squared, because they have the same radius, times by 13. And when we go through and calculate that, we get a volume of 871.27. So once you have those two, the total is just going to be adding these two together, which is going to give us a total volume of 4,619 0.45 millimeters cubed. And that's our total volume. So for part A, because we're adding a cone on top of a cylinder, you have to add their volumes together. For B, we're removing a cone from the cylinder, so you would have to subtract those two volumes. I'm not going to run through all of part B for time, but one thing to note, the height of the cylinder and the cone is the same. So your height that you're going to use for both of them is 4.3. They tell us the diameter of the cylinder and cone is 3.6. That means the radius is 1.8. So you have your height, you have your radius. You need to go through and plug H and R in for both the cylinder and for the cone. You're going to figure out the volume of both of them, okay, which, just to kind of expedite things, volume of the cone ends up being 14.59, and the volume of the cylinder ends up being 43.77. Because we are removing, what that means is we have to subtract these two numbers. So we do 43.77 minus 14.59, and that tells us our volume of 29.18. Centimeters cubed. So I know I kind of expedited and quickly went through that one, but I think by now you should feel fairly comfortable once you know your height and your radius, plugging everything into the formula and calculating it out. So with that said, that is it for today's lesson on section 18.3 for the volume of cones. And we've talked about a litany of examples and provide you with a wealth of problems to reference back at while you work on your homework. So with that said, that is it for today. Thank you guys for listening. I hope this was helpful. And if you have any questions, as always, please do not hesitate to reach out. Either let me know the next time you see me or shoot me an email, and I'll be more than happy to help however I can. Otherwise, that's it for today. Thank you guys for listening. Have a great day, and I'll talk to you later. All right, bye.